yellow fever again. You have all kinds of patients there. What's next? We have types of sets. Then we have finite sets and we have infinite sets. When we say finite sets, like the word finite, it means there is an end. You can determine every member. You can count. You can easily count. Let me put it like that. You can easily count. So a finite set is what? A set whose elements can be found. All the elements of the set can be found and counted. For instance, when we have the set of numbers 1, 2, 3, 4, 5, the last number there is 5. You can find the last number. But if I say a counting numbers, you start from 1, you start from 2, 3, 4, 5, 6, 7, 8, 9, 10. When I ask you what is the last number, you will never be able to tell me. You count to trillions and you can still be counting. You will not be able to tell me the last number. So that one is an infinite set. It's an infinite set. You cannot determine the last element of that set. We have a set of numbers here, B. Set B is what? A set of 1, 3, 5, 7. These are odd numbers, less than 9. Odd numbers less than 9. So once you can count the elements of the set, once you can determine the last element of the set is said to be what? Finite. And the opposite is infinite. If you cannot determine the last element, it's an infinite set. So for instance, the set Q here has 1, 2, 3, 4, 5, 6. And the 3 dots there tells you that up to infinity. To infinity. The infinity we are talking about is the same thing here, infinite. We cannot determine the last number. We can also talk about a null set, which is also called empty set. A null set or empty set is a set that has no element. So when we say element, the 1, 2, 3 to 5 you are seeing there, they are the elements of the set A. The 1, 3, 5, 7 you are seeing here, they are the elements of set B. The 1, 2, 3 up to infinity you are seeing here, they are the elements of set Q. The red, orange, yellow, green, blue, indigo, and violet you see here, they are the elements of that set. The A, B, C, D, E, F you see here are the elements of the set. So the members of that set is what we refer to that as the elements. So a set that does not have an element is called a null set or an empty set. For instance, there are 47 in this class now. If I said a set of all males in this class, they will start raising their hand or they will start mentioning their names and we will list them as a set. When I say a set of females, we will be able to determine them and put them also into another bracket. Then when I ask for a set of goats in the class, there is no goat in this class, so it's an empty set. If I ask for a set of hermaphrodites in the class, even though we cannot prove it, I'm not sure there's any hermaphrodites in this class.
No, we don't have
Unless
them.
the person wants to own up. Connie, do you want to say you are one? Or is
No,
Apia?
I say we don't have one. We don't have anyone.
You know, have you inserted all of them? Speak for yourself.
No, I'm not one of them.
Aha, speak for yourself. You are not one of them. Somebody was Apia. Do you want to prove me wrong?
No, sir. Since
Okay.
we have all investigated, we haven't done any investigation. We can't prove.
We can't prove. So I'm assuming. We are all assuming. So a null set. So if you have your patients in a hospital, you are putting them into various sets. Malaria patients, polio patients, whatever patients, and you previously had diabetic patients as a set. But this time around, for this month, you don't have diabetic patients. Then that set is what? An empty set or a null set. So we use this symbol like a zero with a cross, a line, a slanting line going through. So when you see this symbol, it means empty set or null set. Or when you see the curly bracket, fine. So we use the curly bracket in listing the elements of a set. So you realize that all the sets I've been talking about, we use curly brackets, this bracket. If you use the ordinary brackets, you are wrong. This is the bracket we use for sets. Yeah, that's the bracket. So, but do not put this symbol into the curly bracket and tell me it's null set. This is wrong. If you put a null set into the curly bracket, it's a set of null sets. So it's not an empty set. I'm saying it again. When it comes in the quiz again, which of the following is an empty set? Then you'll be struggling, and tell me that the answer is not there. All right. If you also put zero, some people also think that if you put zero in a curly bracket, it also means an empty set. Never. It's a set of zero. It's not an empty set. It's a set of what? Zero. So A is the set here, a set of zero. So when we ask you what are the elements of set A, you will tell us that zero is the element of set A. Good. Another type of set we can talk about is a unit set. Unit set. A set that has exactly one element. A set that has exactly one element. Only one element in it is called a unit set. There's another vocabulary for it, singleton. You write the word single and add T-O-N, singleton. It's also a unit set. That is a set that has exactly one set. Unless Prof is online, when I'm counted among the 47 online now, and we say find the set of lecturers in this class right now, I'm the only one that will be in that set. Prof, is Prof online? Prof. Okay. Let's assume Prof is not online. So if Prof is not online, I'm the only lecturer here. So the set of lecturers in this class right now is only me. So that set is a unit set, a singleton. We're almost done, don't worry. Then the gymnastics begin. Subset. Subset. If all the elements or members of set A can be found in another set B, then we say the set A is a subset to B. You are level 200 students. If we have set A equals to level 200 students of Nyakote University College, then we have another set, students of Nyakote University College. You and I will agree that all the level 200 students are students of Nyakote University. So the set of level 200 students is a subset of students of Nyakote University College. Let's come to your hospital. You have a set of all, you have a set of your patients who have diabetes. Then you have another set of patients who have hypertension. You know, these two diseases, they like moving together. Most likely, okay, let's assume all the diabetes patients, they have BP. All the diabetic patients, they all have BP. But there are some BP patients who don't have diabetes. So we say the set of diabetes patients is a subset of the set of BP patients. BP patients. That is to say that all diabetes patients, they have BP. But not all BP patients have diabetes. There is another interesting topic ahead we'll be doing. We call it logical reasoning. Logical reasoning. We'll cover all of them. The statement I'm making now, we'll meet it when we get there. So all diabetes patients have BP. So it means that the set of diabetes patients is a subset to the set of BP patients. In other words, the set of BP patients contains, when we use contain, this symbol means a subset. So A is a subset of B. But when we turn it around, you look at it, it looks like C. But when we turn it the other way around, so that the opening goes to A, then that one means contain. I think there is an example ahead. We have to see. Okay. Okay, so we write A is a subset of B. This is how it's written. It's also read as what? A is contained in B. Let me just search something quickly. Insert symbols. Where are you? Let me see you first. Let me see you first. Let me see you first. Okay. So we can write this same statement B contains A. Set B contains set A. So this is the symbol for contain. Or A is contained in B. So the most important thing is the bigger set will have the opening of the symbol. The opening of the symbol should tend to the bigger set. So A is a subset of B. If you are bringing the B first, then the opening should come there, like you are seeing here. B contains A. That means A is a subset of B, or every element of A can be found in B. Universal set is a set of all the members or the elements under discussion. So I just talked about level 200 students and I talked about Nyakote students. Maybe we want to talk about level 100 students, level 200, level 300, level 400. So set A is level 100 students, set B level 200, set C level 300, set D level 400. Who are all these people? They are all students. Students where? Nyakote University College. So the biggest set, Nyakote University College, is the universal set. So when you are talking about BP patients, asthma patients, polio patients, typhoid patients, malaria patients, etc., they are all what? Patients. So patients has become the universal set. Then we have the subset to be the various sets of, the sets of the various diseases I mentioned. If you are talking about okra farmers, maize farmers, yam farmers, banana farmers, etc., they are all farmers. So farmers has become the universal set. So the universal set is the umbrella set that encloses everybody, all the subsets. Equal sets. Two sets are said to be equal if all the elements in the first set can be found in the second set, irrespective of the arrangement. If all the elements in set A can be found in set B, then we say set A equals B or set B equals set A. For instance, you have a set of this number 2, 3, and 5. Then you have set B 5, 2, 3. Even though the arrangement differs, you agree with me that 2 here can be found here. The 3 here is also in the other set. The 5 here is also in set B. So since every element in A can be found in B, we say that the two sets are equal. None is smaller than the other. They are, somebody will say they are co-equal. Look at a trick here. We have another set A, 1, 3, 5, and 7. Then another set B, 3, and 5, and 1. You agree with me that 1 here can be found in B, 3 in A can be found in B, 5 in A can be found in B, 7 in A cannot be found in B, and we have N in B that cannot be found in A. But if you have additional information that set A equals set B, then of course, you don't need any rocket science to know that the N here represents the 7. Given that set A equals set B, then the 7 we are seeing here, which we cannot see here, and the n we are seeing here, which you cannot see in A, represent each other. So your n equals 7. Equivalent set. Equivalent sets. If you have two sets, A and B, and the number of elements in A is the same as the number of elements in set B, then the two sets are said to be equivalent. Please pay attention very well. Equal set and equivalent set have been confusing people a lot. For equal sets, we are saying that the same elements in A can be found in B, and all the elements in B can be found in A. So none of them is bigger than the other. So they are equal. But under equivalent sets, we are saying that the number, here we are talking about counting. The number of elements in set A is the same as the number of elements in set B. Then the two sets are equivalent. Two sets are said to be equivalent if they have the same number of, not the same element, but the same number of elements. So we have a set here A that has 2, 3, 5. Then another set here B, 11, 12, 13. Even though we don't have all the 2, 3, 5 in B, neither do we have 11, 12, 13 in A, we say the two sets are equivalent, but they are not equal. Mind you, every equal set is equivalent. Every equal set is equivalent because the first condition under equal set is that what? All the elements in the first set must be in the second set. If all the elements here are there and all the elements there are here, then it means the number of elements we have in A is the same as the number of elements we have in B. So if you come here, 1, 3, 5, 7. When you come here, 3 and 5 and 1. So how many elements are here? We have 4 elements here. How many are here? We have 4 elements. Therefore, the two sets are equivalent. Even though they are equal, they are at the same time equivalent. So all equal sets are equivalent, but not all equivalent sets are equal. Bear that in mind. Disjoint set. We should have talked about intersection before we talk about disjoint. But that is fine. If you have two sets such that they don't have anything in common, set A and set B, there is nothing in A that you can find in B, then the two sets are said to be disjoint. They have nothing in common. And their intersection is a null set, or their intersection is an empty set. So that brings us to intersection. What is intersection? If you have two sets, let's look at this one. Let's not consider n equal to 7 for now. We have A equal to what? 1, 3, 5, 7. B equals what? 3 and 5, 1. Let's end the statement there. Let's close our eyes over this one. So what elements are in A and can be found in B? Or what elements are in B that can be found in A? You realize that we have 1 here and is here. We have 3 in A and it's also in B. We have 5 in A and it's also in B. We have 7 in A and it's not in B. We have N in B and it's not in common. Sets We have A, 2, 3, 5. We have B, 11, 12, 13. There is nothing in A that can be found in B. There is no element in A that can be found in B. And there is no element in set B that can be found in set A. Therefore, they are disjoint sets. Their intersection is empty. It's a null set. Any questions so far? Any questions so far? Confused or convinced?
Oh, we are convinced.
Sir,
Yes.
if you can move over to disjoint set, that one.
You want me to go over disjoint set? Okay, look at the set P. The set P has elements 2, 4, 6, and 8. The set Q has elements 1, 3, 5, and 7. Is there any element in P that can be found in Q? Or is there any element in Q that can be found in P?
No, sir.
Aha! They don't have anything in common. So they are disjoint. Once you cannot see something in P, that is also in Q. Or you cannot see anything in Q that can be found in P. The two sets are what? Disjoint. They are not connected. They are not joined. Any other question?
Sir,
Okay. Thank you, sir.
Yep. With pleasure.
okay. Sir, please. Okay, so with the same scenario, P and Q, we can say that they are equivalent. They are disjoint sets.
Perfect.
Okay, sir.
Perfect. How many elements are in P? We have 1, 2, 3, and 4.
And 4. Yeah.
How many elements are in Q? 1, 2, 3, and 4. So they are equivalent sets, but they are not equal, and they are disjoint sets.
Okay. Okay.
It
Which
means
also means
learning
that
has taken place.
we
Yes,
can use the same words like equal set means same thing, and then equivalent means similar. I don't know if I like in a simple
Come
way
again,
to
come again.
explain. Let's say so we can see
Come
that
again.
equal sets are the same thing. Let's say when you find the same thing in two different sets, they are equal sets. But if you find similar members, so let's say similar, not necessarily the same, but once you can count the same number of elements, so about 5 here, 5 here, then they are equivalent.
Good. So for equivalence, the emphasis is on the number of elements. For equivalent sets, the emphasis is on number of elements. But for equal sets, the emphasis is on what? Same elements. The same thing here can be found there, or the same thing there can be found here. And disjoint is saying that they don't have anything in common.
Okay, sir. Thank you.
Great. Any other questions? Oh, today Prof is not online. Okay, if no question, then we'll end it here. We have 11 minutes to 10. We'll end it here. Let me quickly add the question to that slide, and I'll drop it on the page for you. And this caters for last week and today. So if no question, then have a good night. In your dreams, you should be seeing yourself on top of calculations of all these things.
Yes, equivalent dreams.
Then when you wake up tomorrow, then you should be on top of the calculation.
Our dreams will be disjoint dreams.
Hey, your dreams should be disjoint from the lesson. Well, the most important thing is at the end of the day.
Not from the lesson, but everyone will have different dreams.
From each other.
Yes.
Okay.
But maybe
I'm just glad
equivalent ones.
you are applying the vocabularies.
We should all have equivalent dreams because we have
Not more than schema F.
in the lesson.
Thank God you are using the vocabularies perfectly.
To apply it in life will be a problem.
That name IM or IG something. Ingrid.
Okay.
I think it's
Ingrid.
Ingrid. Are you confused or you are convinced?
Well, I'll be having a call with the class rep. He seems to be very good, so I'm going to give him a call. It needs practice. It definitely needs practice.
It needs practice. That's the underlying information. Sorry.
Yes. Thank you.
Yes. Yeah. Who also? Hey, Moses. Who is Moses? I've not heard you talk before.
Yeah, please, I'm here.
Good. Dr. KB.
Sir, please, I'm the one.
Oh, okay. Yes. Christiana.
Please, I'm here.
Great. We've not been able to take attendance. Last week attendance will be all those who took part in the quiz. So do I create because it will be unfair for some of you not to be attending lectures, and at the end of the day you all have the full mark for attendance.
Okay, sir, we do normally take attendance. What we do is that at the end of every lecture, mid lectures, and also at the end, Madam Charlotte takes a screenshot of all of us in class, and then she posts it on the course rep page. So we normally do take attendance. We have it if
that's fine.
Can push them to.
That's fine. Okay, there's no problem. So course rep, I'll be relying on you for that, but I will surely create a link next week so that you just go and enter your index number and go away.
That would be great.
You just the link. And that one, just after the class, the link will close. You can't enter again. Okay, then let me leave you here and have a good night.
Please, the name with Moses. The name with Moses. I thought you are coming to rescue the Israelites.